Thank you for the invitation. I have been in this technology for the last over 30 years and have done some work 20 years ago, 15 years ago in Hawaii with the USDA, as well as with a few companies. Those were the days when the machine was very expensive and not very reliable, but we've come a long way. So I'm happy to see the interest in Hawaii currently. I will just give an overview of the technology, and then we will look at commercial applications. So we'll look at what is HPP, how it works, very few bits of information on microbiology as far as food safety, shelf life, and validation studies are concerned. A little on chemistry and nutrition, packaging. This seemed to be almost always lagging behind the application. So we'll bring you up to date on what types of packaging are used and some of the requirements. And there'll be a lots of examples of commercial HPP products, so you have a better idea of what the packaging that is being used currently and the types of foods. So what is HPP processing? HPP is generated by the compression of water. This is important to know because in the earliest studies that were done, we were using medium other than water, castor oil, propylene glycol. Those type of results you get tends to differ a little from when you're running water systems. So be careful when you're reading some of the older literature and the conclusions they made. Pressure induces physical, chemical, and biochemical changes in microorganisms and certain food components. It is a non-thermal process that inactivates microorganisms and, excuse me, I just get my pointer here. And retains the freshness, nutrients, and flavor of the foods. These are some of the major drivers of the technology, particularly in the beverage, in the ready meals, the baby foods, the pet food industry. It is a natural process that eliminates the need for chemical preservatives. No one is using sodium benzoate or potassium sorbate in their food if they're using HPP. Some companies do maintain some levels of what we call natural inhibitors as a synergistic components to pressure, depending on what their formulation and food is. Just to give you an idea of the type of pressure we are using in an HPP machine, if you take a look at the deepest part of the ocean, which is the highest pressure, it's the Challenger Deep in the Mariana Trench. It's just 15,000 PSI. The areas in green are what we use in food processing. For non-microbiological applications, like the tenderization of meat or the de-infestation of fruits or so, can be done at very low pressures. The next level is for the shucking of shellfish. We do that roughly at 45,000 PSI at an average. We don't get significant microbiological benefit other than Vibrio bacteria. Vibrio is very sensitive to HPP, and it can be inactivated at those low pressures. But the bulk of the food is done in the hatched green bars here. If your food is acidic, you tend to use lower pressures and even shorter hold times. If it's a low acid product, we tend to go to the maximum of 87,000 PSI. And the time under pressure will vary depending on intrinsic factors of the food itself. The red bar is research. This is a machine we have in Chicago at one of the institutes. And we look at this as a sterilization system, not a pasteurization system, in which we use heat and pressure to get rid of Clostridium botulinum and those other organisms that we normally target when we are doing retorting. So these two areas here, the hatched green bars, are what we're going to be talking about most of the time here. The way the technology works is foods, hermetically sealed products are put in a basket. That basket is put into the vessel closes, and then water is added to the vessel. After the vessel is filled, the intensifier pumps turns on. That is what generates the pressure. And it is generating pressure by adding more water into an already filled container. So the only way you can do that is make whatever is in that container smaller. Water actually compresses about 15% of its volume at 87,000 psi. So it gets smaller, the food gets smaller, the container is actually under that same type of pressure. So that will relate to what type of containers we use. At the end of the cycle, the water is recycled, products are packed off, and another filled basket is used to take out the baskets that have already been high pressured. Some of the principles of HPP that makes it so attractive in the industry is that pressure is transmitted uniformly and instantaneously throughout the product. If you take a look at the mannequins, the styrofoam pieces I have on the right here, there is really no deformity because of the evenness of the pressure all around. We purge the air out of the styrofoam and you have a smaller head than a bigger head. Same thing with the ball and the cup. Process time for microbiological inactivation is independent of product volume and size. This is different from heat. So if I am taking a 100 gram of ham, I can run that with 50 kilograms of that same ham under the same conditions in the same vessel at the same time, because there is no difference in the product volume as far as it's seeing the same amount of pressure. Flexible packages are used for HPP, and it must be able to compensate for at least 15% compression. If you have air spaces inside, then you will need additional compression. So a lot has to do with how it's packaged. If it's not, if you take a look at the cans I have here, I have a Thai coconut milk. It was compressed, but never come back to its original shape. But the bottle, which is a compressible, and after HPP, it actually gets back to its shape. Minimum headspace is good as far as package integrity, economics, and organoleptic. You don't want to really run a lot of air packages with a lot of air, because you can damage the packages, number one. Number two, you can have some sensory issues, especially if that air contains oxygen. And we'll touch into that a little later. I did mention that it's a non-thermal process earlier, but heat is given off during HPP. As pressure increases, the temperature increases. It's an average of 3 degrees Celsius for every 1,000 bars. So if I'm running at 87,000 psi, you will touch a temperature 18 degrees higher than what you start with. That temperature remains about the same throughout the cycle. But at decompression, you're back to where you start, plus or minus 1 or 2 degrees. So you don't have any lingering thermal effect of the pressure and that compression heat. So all the scientists and all regulatory agencies have give their blessing that this is a non-thermal technology. It is not a thermal technology, because this heat that is generated, we don't rely on that heat for any microbiological benefit. It doesn't really give you 18 degrees Celsius. It's like cold room temperature. So what are the benefits? Inactivation of pathogens. This is the first reason why this technology was basically looked at. How can I make a food safer by get rid of pathogens? It is being adopted in the industry to protect customers or users of the technology from safety recalls, food safety recalls, to protect their brand, but also to meet global regulatory requirements. In the US, we have requirements for juice pasteurization and the 5-log reduction. We also have regulations as far as the control of listeria in the deli meat plants. HPP has been approved for those processes. The fact that you're not using any heat or preservatives, you get a cleaner label. This is a high consumer demand or appeal to them. And you also maintain the fresh taste. There is no damage to nutrition. There may be in the literature showing that there are damages, but if you take a look and when those conditions were run, most of those studies were done in which temperature was not controlled and they were higher than what we are using in commercial applications. There is no damage to bioactive compounds, such as antioxidants and certain enzyme systems. And this is very attractive to several segments of the food industry. We'll touch on it a little later. You can use, you get all the raw quality. There was a case in California in which the judge has ruled that HPP juice can be labeled as raw. You can't label it as fresh, but you can label it as raw. But I think one of the biggest thing that really expand the application is the increased shelf life. You inactivate the spoilage microorganisms along with the pathogens. This extends your shelf life, but it also extends the quality of the product. In conventional technologies, when you have a product, let's say you have a sliced meat product and you have it in the market, you find that as you approach the end of shelf life, there is a drop off in the quality. There's purge and color changes. Some of the stores will put it on sale so that they can get rid of it but it's not an unsafe product. However, with HPP, that quality goes to your end of shelf life. It even allows you to reach wider markets. In the earlier days, when you had certain products being produced, they were being sold in one regional area. I remember giving a talk in Singapore, and we were able to go to the local store and buy the HPP Hormel meats because ours were seasoned custom. So you're able to get this longer shelf life, you can get into different markets now. One of the very important part is that HPP offers new development or product development opportunities for a couple of reasons. One is that their unique behavior on starches and proteins, that you can really harness those changes to get a product that actually have a better mouthfeel, more creamy. You can also make formulations with high nutrition inside without knowing that you will not lose it after that process, which is different from what you would see with thermal processing. Another benefit, and this is really very big in the avocado industry, in the apple industry, you can take perishable raw material that is not marketable in most cases, that like apples, they were usually sold as animal food. And you can make a product that is actually a higher value than the raw material. This has really driven a lot of orchards to implement HPP systems. Typical processing conditions, pressure or microbial inactivation, as I showed in the 2 hatch bars, is between 4,500 to 6,000 bars, which is basically about 70 to 87,000 PSI to get the microbial benefits. This is different from heat. Heat, we have something called a low temperature, long time process in which you use low temperature over a long period of time to maintain some of the nutritional benefits. But in HPP, when you're using it to inactivate microorganisms, there is a critical pressure that you need to reach, depending on what the pathogens and the spoilage organisms you're targeting. Generally, the hold time varies from 1 minute to 3 minutes, and it depends on the pH, the Brix, which is the water activity, as well as ingredients in that product. So when we're dealing with a customer and they want to know what kind of a processing conditions to use, they will provide us with this information. And instead of going and do a study, determine what the information is, we have the data, we can say, this is the condition you need to use. Process temperature, I have a very wide range here, but normally most food is processed between 4 to 6 degrees for organoleptic and functional reasons. The reason I have 40 degrees here is that in some applications in the seafood industry for shucking, you can enhance the shucking by raising the temperature. So for lobsters and so that we don't do it at 4 to 6 degrees. We increase the temperature. Sometimes some companies like to form up certain types of seafood items, and you can form it up by actually using temperature as a functional part rather than a microbiological benefit. If you use high temperatures, like say greater than 10 degrees Celsius, you can have some production issues. You can have meat slices that stick together because you're having gelatinization of that protein, and what are the components they have inside. It forms a glue because it's a temperature plus the pressure and the adiabatic you have can cause this, what we call gelatinization of the starches and protein. So basically, temperature is mostly a functional aspect of the application of HPP. Microbiology, normally I would have about 10 slides on microbiology. I have one slide here, so that's really good. We target bacteria, parasites, viruses, yeast, and mold. The more complex the organism is, the easier it is to be inactivated by HPP because there are more things in that organism to be affected by pressure. So on one hand, parasites will be the most complex of organisms. That is why I mentioned earlier, some of the parasites in seafood can be inactivated at 20,000 to 30,000 PSI. Viruses, on the other hand, is a very simple organism. It's just a piece of protein and genetic material, and it is more difficult to inactivate. We do not do much on viruses in food applications because there are several studies we can fall back on. Even coronavirus, not the COVID-19, is susceptible to pressure if you use the right conditions, because there have been some published work on coronaviruses. Our target is mostly bacteria because all your pathogens we're dealing with are within this group. Yeast and molds are more easily affected. So we know when we target bacteria, we will get rid of yeast and molds, depending on the food. There are times when we have a syrup that has a very, very high Brix, that yeast and mold becomes the target organism that you're looking for. A little bit on the pathogen validation. I think Colin asked me to put some information on this. We follow regulatory recommended procedures. This is published by the National Advisory Committee. I have the reference here. It was published in 2010. However, there are changes to accommodate HPP. The reason being, HPP affects bacterial cells differently than heat or chemicals. So we do modifications of that, and there are several steps that we will use: the incubation time, the media, etc. However, they don't deviate from the recommendations from the National Advisory Committee. It's just that you're compensating for the differences with HPP and how it affects microorganisms. For instance, one thing, we do not kill bacterial cells under pressure. We inactivate it. That is, we injure it so much that it takes a while to die off depending on the conditions of the food. we find that 24 hours is the median in which most bacterial cells will either complete the inactivation if the HPP conditions are correct. If they are not correct, that they're on the process, those cells have an opportunity to recover. So if you really want to know what is going on, wait under 24 hours. For acidic product, this can happen within 6 hours. For fresh meat product like we do in raw meat is almost like a microbiological media. So most companies will wait 48 hours to do that initial micro to understand whether their conditions was appropriate for inactivation of whatever level they're targeting. The other thing is that you cannot use nucleic acid-based testing, which is recommended by even a National Advisory Committee, FDA, BAM, etc. The reason is HPP has minimal effect on DNA. So if you use a PCR-based test, you will get a false positive. The cells are inactivated, completely inactivated, but the DNA is there. And if you use the test, it will show as a positive. The FDA actually had this problem in the earlier days when they were assessing the HPP effects in some raw meat. They were using a DNA-based testing, and they were getting the false positives, and they were actually giving the toller a very hard time that the conditions were not correct. When we looked at those procedures, we found that they were using DNA tests. Now they don't, so that is good news. We do not do validation with Clostridium botulinum. The reason being HPP on the commercial applications has no effect on Clostridium botulinum. We do know that most of the spores of Clostridium botulinum do not grow at refrigeration. Everything we do with HPP is refrigeration. But there's certain strains we call the non-proteolytic strains of Clostridium botulinum, type B, type F, and type E, which is marine strains. Those can grow at refrigeration as low as 38 degrees Fahrenheit. So you have to have in your food certain hurdles that you built in. And these are listed by the FDA. The USDA also uses it. Health Canada uses the same thing. So you have to build in your food certain conditions that will inhibit non-proteolytic Clostridium botulinum from growing and produce toxins. Another step in the validation is that samples need to be run in triplicate or duplicate. In most cases, the FSIS requires triplicate. You can get away with a duplicate for FDA because more of the work was done with FDA, so they have a better knowledge of how HPP works. Your length of storage during validation study should be at least 1.25 times the shelf life. If it's a long shelf life, if it's a short shelf life, it's 1.5 times the shelf life. So a 60-day shelf life product will be analyzed through 90 days. Health Canada has just insisted on that, and they have dropped to 1.25. US, we can still make that determination ourselves. The cost of a pathogen analysis, which is something that Colin had asked me to put in, it varies from about $10,000 to $12,000. And that's for duplicate samples running 3 pathogens. The ones of concern are Listeria monocytogenes, Salmonella, and E. coli 157. And also one condition. If you're doing a shelf life only, just a shelf life, it's about $2,500. If this was a part of the pathogen study, as most companies will do, then this is less. This is about $500 per sample. The $2,000 here is added for a use of the laboratory and technician's time. A few more notes on validation study. We have a very huge library of reference studies. We have been doing these validations over 25 years now, and we have done it not only for customers, we have done it in-house so that we can feel more comfortable talking to customers, but we have also done them to submit to FDA and to FSIS for approval, as well as to Health Canada. Sometimes if one of your clients or you need a validation study, instead of running a validation study, we can provide a process authority letter and reference the studies we have done before. But we will need to know what the pH, water activity, and other constituents of that food is to make it, a very strong letter. We have done a lot of these, and none of them have been actually refused by regulatory. And the data that you accumulate during the validation study is important, either whether you get it through a letter or whether you do the study yourself, because you use that to set the CCP for HACCP programs. And normally when these validation studies are done, it is important that you do it lower than the actual production pressure. Validation studies for us, if we are running a product at 87,000 PSI, we will validate at 86. Because during that cycle, there will be a drift in pressure downwards, depending on what the hold time is. So if you are validating at 87 and you drop below it, you have violated your CCP. So that's one note in how to conduct these validation studies. Chemistry and nutrition. HPP, a gelatinization of starches, can improve sensory attributes. Things have better mouthfeel. They're more creamy to them. We also have hydration of proteins. This is huge in the seafood industry because a lobster will increase by 7% in weight without adding any chemicals, none of the phosphates, just by the hydration of proteins. You can also, as I mentioned earlier, decrease or inhibit purge. So when you have end of shelf life product, that you will not have liquid developing in the packages. It also prevents syneresis. So most of you know, if you go to the store and you buy, syneresis, by the way, is the separation of the solid to the liquid. If you go and you buy a tub of yogurt, you will find the whey floating on top. If that was HPP, you wouldn't find it because all of the liquid will be incorporated in the protein structure. This was very helpful when we were helping one of our clients in developing yogurt-based salad dressing that is very, very successful here in the US. HPP does not affect covalent bonds. This is very important to note. So we don't break proteins. We will unfold proteins, but we do not break those bonds. So you have vitamins and bioactive compounds are not affected. This, as I mentioned earlier, is a huge benefit to the beverage industry, the baby food industry, and the pet food industry. Those are the ones that look specifically for not affecting any of their bioactive compounds. There is no significant effect on enzymes, and that's a cop-out when you say there's no significant effect. It's not a yes or no. Some enzymes, depending on where their active sites are located, can lose activity, but major food enzymes are not affected. For instance, PPO that causes enzymatic browning is not affected, but it's very easily controlled by using the right packaging, doing the right deaeration of the product, or packaging on the nitrogen so that we don't have residual oxygen inside. Pectin metallesterase that cause the breakdown of pectin material is not affected. But most of the companies, especially in the beverage industry, they like that in the sense that they love to see the separation, the clearing of the dissolved pectin. I know Starbucks was one company I talked with. We want to see that because we know when we add heat, that doesn't happen. So now it is a proof that we are not heating our juices. So in some ways it can be good. In some ways for food processing, it can be a nightmare for certain products. There's also improved digestibility of food components. There have been quite a few studies, especially out of Japan, that shows that starches are more susceptible for breaking down by amylase enzymes because they're high pressure treated. There's a lot of rice that is being HPP'd in Japan, in Taiwan, in Korea. That is not for microbiology. They do it for three different reasons. One is for this digestibility. Two, there are certain allergenistic compounds that are present in rice that you can get rid of with HPP, especially for the elderly population. And the other benefit is that if you it's HPP before cooking. So if you HPP the granules, they do not break when you cook it. So you have the unique grain. The Japanese are very, very particular in how their rice grains look. So this was something that was in the market now for about 15 years, and they're still producing a lot of it. Before we introduced the technology in Canada, Canada was under this novel process, novel food ruling, and HPP was one of that process. By the way, about 4 years ago, they lifted it after they have gotten a lot of proof that this is not a novel technology anymore. We had to show that vitamin C, folic acid, and niacin are not affected by HPP. And we have done a lot of studies in using outside laboratories like Medallion and Covance laboratory to show that none of these happen. We looked at different pressures and times, and vitamin C, folic acid, and niacin remains the same. We have done this study over and over to show that that doesn't happen. So we are very confident when we talk to customers that it doesn't happen. You tend to lose some vitamin C over the storage of time in these clear plastics because they're very, vitamin C itself is very susceptible to light. So that you can lose that over a period of time. But HPP really has no effect on it. Chlorophyll, lutein, we have actually done some studies to look at different temperature effects at pressure to see whether it will affect these two very sensitive compounds. You can see the line actually goes up for chlorophyll. We're not putting more chlorophyll inside, it's just that HPP was releasing more chlorophyll from the cells, so the equipment can actually detect it easily. Lutein, the same thing. So, and there have been several publications. We've actually done one with the University of British Columbia working with echinacea, showing which has some very sensitive bioactive compounds, and none of it is actually affected. Packaging requirements. These are some of the packages that work well with HPP, cups and tubs and trays. One of the things that you have to be careful of is the sealing area. You have to have a wide enough sealing area or you will compromise that seal with HPP. There is more compromise if there is a lot of headspace. So there's more to actually shrinkage of that package and the top film. In most cases, the top film is a weaker film, so this is the one that will go first. Tubs work very, very well. This is the Hope Homicide of Colorado. One of the new things that has been really successful is what we call skin packs, in which the product is actually vacuumed onto the tray. So you have good definition of the product, as well as no air inside. And a lot of the ready meals are being done with HPP in this form right now. Bottles, PET, HDPE works very well. PET is the most common, maybe 90% of the bottles for juices are done in PET. There are issues with closures. If you don't want to use an induction seal like we have here on this bottle, which no HPP company really wants to use, you have to use specially designed caps. These are manufactured by Berrycap, by Silgan, Captiva, and others. China has several manufacturers now of these type of caps that all work because we have tested a lot of them. It has this membrane inside of it, and it has a tapered edge here. It gives you a wider turk to deal with, so you're not really over tightening to get it sealed. It's just the way it's designed that water doesn't go in. There is another advantage in using these styles of caps. During filling, you would have overflow before the cap goes on. And with these long shelf life we're getting, if you don't wash that region, you can have mold growth. So these have a wash channel, that is a discontinued thread on the cap so that water works itself in. So HPP will, during the pressurization, would actually clean that area. This is a company in Korea that they were having leakage problem because they were using a standard plug cap. After they switch to these double seal caps, they don't have that problem anymore. Other examples of packaging. Here we have a cup. This one actually has an aluminum top on it. This is one of the first companies. This is a company out of Montreal, Canada, that actually put, they call Apple Snacks, Leahy Orchards, and they actually done this for several years now. They also have a tube material that you can actually not only just use it as a refrigerated item, customers will buy it and freeze it so you have a natural food, like a apple-based popsicle that you're using in the summertime. This is one type of packaging, these tubes here, pineapple, mango, grapefruit, that's packaged like this, is almost like a snack. This is a product that is done in Australia. It's mostly like a food service item that you use for toppings. And here is an example of one of the skin packs. This is one like the earlier package. This is a company out of Barcelona, but you can see the wide ridge that they have here for the sealing area. Avure also has just developed what we call a post-HPP filling system. It's called FlexiBulk. It's for beverages and pumpable foods. So what you're actually doing, you're HPPing your product in a container, and that container is emptied out, or product is pumped into an aseptic clean fill system. This gives you the opportunity to use any type of containers like glass, which we don't use in the HPP business. You can use that. And this is not, it's a unique way in doing it, but it's not new to Avure. Back in the 90s, we used to sell a continuous vessel in which the juice was pumped into the vessel. And even guacamole was done that way at one time. It's pumped directly into the vessel, and then it's pumped out into an aseptic filling tank, and then they do their packaging. We don't make those systems anymore. They were very, very difficult to maintain the CIP, and they had other problems, but it was a product that was made by Flow International instead of Avure JBT, because Flow at that time was the owner of Avure. What this allows you, this FlexiBulk system does, it allows you to get larger volume per cycle. This obviously decreases your cost. You're getting more product in through cycles. If you're putting bottles in, you get about a 50% loading efficiency. If you're using one of these FlexiBulk system, you're closer to 85% loading efficiency in those bags. It also decreases waste, and you can reuse some of these bags that are pumped into the system. It's sort of like the trolley bags, large bags with a knob, a valve that you will take out and transfer the product. I don't have too much on this, just one slide. For commercial applications, I have a sort of a pie chart here. There are three product categories that really dominates the application in HPP. Ready-to-eat deli-style meats. You have dips and spreads, and juices. However, seafood has been a very big and steady category for us. But now we're seeing ready meals and some other applications are starting to come on, including dairy-based items. So we're having expansion, but you still have about three categories that does the bulk of HPP for several reasons: food safety, shelf life, and nutrition. As I mentioned, HPP meets the FDA 5-log pathogen reduction rule. We submitted data to FDA in 1999, and this rule came out in 2004, in which they accepted HPP as a way to get rid of Salmonella, E. coli 157, and Listeria monocytogenes. On the FDA's advice, we also ran a Cryptosporidium parvum, which is actually the oocyst of a parasitic pathogen. It's not an easy organism to work with. So we did the study, published it, and when customers need it for regulatory, we provide them a copy. Health Canada has since done a study also. So there are two studies that are available so that you don't have to do validations on those in your laboratory. It's a very difficult organism to work with, procedural wise, as well as infection wise. So most laboratories don't run it routinely. You also tend to have spoilage bacteria inactivated disease conditions, as well as yeast and molds. One of the new things is these juices now with gas. You can do a carbonated beverage with HPP. You're having some compression of the CO2, but one of the things that companies that we have advised companies to do is overcompensate on the carbonation. So when you go back to atmospheric conditions, you still have that big amount of carbonation inside, and you don't get a flat beverage after that. This is some examples of Starbucks products that is being done in Korea and are actually being sold all over Asia. There's several other product lines that they have. They do it not only in Korea, they do it in Taiwan and other places. Other examples, including this Drought is a company out of Detroit. You have this Genesis is an interesting one. This is actually the first HPP juice in the US market. It was never meant to be HPP. It was being done by Pulse Electrical Field. That company went bankrupt. It was bought out because of failure in the post-process system, because with PEF, you have to post-fill. You don't apply PEF to a fill bottle. So this company out of Oregon bought it and have since been actually marketing Genesis juice. You find it more on the West Coast, not so much on the East Coast of the US. Some interesting ones. You have a lot of these immunity beverages now. We call them shots, health shots, immune shots, whatever marketing will find to put on the product, they put the Wellness Blast. What it is, it's a more concentrated form of turmeric and ginger and other materials that have proven over the years to be good for your immune system. This category is being driven a lot because of the pandemic. Everyone wants to buy something that will increase their immunity. So shots are doing very, very well currently, because not only because of the pandemic, but it's not a whole lot of liquid to drink. So it's almost like taking what they had, these 5-hour energy drink that you have with a lot of caffeine. This is similar to that. Is a small container that you just drink, and you get all the benefits of the fruits and vegetables inside. Some of the new things in the market are drinking vinegars, mostly apple cider vinegar, and fruit or water-infused fruit. Pieces of pineapple or mango or lime is added to a bottle of water. They sell this thing for over $8 a bottle. It's just a bottle of water. However, it falls under the HACCP rule because it has a fruit inside of it. Wet salads, dips, and sauces. Avocado, as you know, is one of the first successful products launched in the US back in 1997. And now everyone is doing it around the world. Here is avocado fresh, Avo Fresh in Australia, Mr. John Riley's customer. We have Avalanche in South Africa, and Gordian is out of Guatemala. But you have, this was all started by Avomex. Now they're called Holy Guacamole. Avomex with Mr. Bowden are the ones who started to market HPP avocado products, not just guacamole, but they were also doing these tubs for food service. But you can see Sabra, which is a Pepsi-owned company, Del Monte, Alavo, bigger companies are also involved in this. The funny thing is, this industry is not slowing down. The only thing that is keeping them a little on the slow track is the availability of avocado. Wet salads, so you have several of these now in the market. This is an example of how they're packaging. You have potato salads and pasta salads, quinoa salads. We also have some new crab salad items, seafood items that you have to meet some Clostridium botulinum guidelines from FDA because it's a seafood item. But more and more these items are becoming very, very popular now. Not just in the US, we see it in Canada and we see it in Europe. Even Asia now are having some of these ready-to-eat salad items. Salsa, it all started with Garden Fresh out of Detroit, Jack's Special. And from then, we have several companies. Casa Sanchez in California makes several new formula, mango habanero and some other types. This is one of our very good customers. Jack's Salsa here, this company, the owner just a few months ago passed away. However, they are still producing a garden fresh salsa. And you can find it, this container here, you can find it at your local Costco. Mango is becoming very popular. We're doing mango in Spain, we're doing mango in Mexico. This is a mango item that is actually being introduced into Germany, either as a salsa, as a pulp, or as a fruit, as a dessert item. But mango is really become popular with HPP now. And I know at one time I had met with the mango producing company in, I think in Maui, in Hawaii. And as I said, in those days, the equipment was too expensive. But the interest has always been there. And now that we have better equipment at cheaper cost, this industry may really go further. Seafood, several types of seafood, raw shrimp, cooked shrimp, bacalhau, which is that salted cod, is very popular in Europe. We do it in Portugal, we do it in Spain, as well as in Italy. This is a company out of Greece, Mytilus. This is one of their new product, which is a carpaccio, which is a fully cooked octopus. Crab is very popular. Whole bacalhau can be done, whole fish can be done if they're gutted and headed, and they can be packaged. If it's fresh, you get about a 30-day shelf life at refrigeration temperature. No longer than that because it's a fresh fish. If it's cooked, you get a longer time. Oysters, this was all started with the motivated seafood out of the Louisiana area called the Gold Band oysters. They've won several awards in Louisiana on the taste of the oysters. Now everyone is doing it around the world. Actually, we're doing oysters even in Australia, I think. But this is how they're normally marketed. They have a band around it. All the customer has to do is open this, and the oyster is already shucked inside. Or you can actually shuck the meat and then put it in a container and sell it as a finished item. So oysters have been very, very popular. There is also oysters that I thought that they have at Costco now, which is an HPP oysters that is actually frozen. The HPP, they take it, put it on the half shell, put a glaze over it, vacuum packed it, and sell it as a frozen item. Lobster, this is how the lobster, how much of the meat you get out of the shell. You get all the meat out of the shell. This was done by one of my lab technicians, kind of reassembling an HPP shop lobster, but it's a huge business. A lot of it is actually done in the Northeast of the US and sold to sushi applications in Japan mostly. in Korea and Taiwan. Although restaurants in France and Germany do buy HPP lobster to serve in their restaurants, but you can do it either like this, chuck it, freeze it in what we call an icicle pack, or you can repack it. And normally lobster is done about maximum of 50,000 PSI. If you want any refrigerated benefits, you can pack it and then reprocess it at a higher pressure to give you the maximum shelf life you can possibly get with a refrigerated item. Crab is a Dungeness crab, snow crab, king crab. The quality of the crab meat, excuse me, is a lot better with HPP compared to the way it's being done right now. Crab is picked by cooking it and then picking the meat. You get about 25% of meat to total weight of crab meat. Same thing with lobster. With HPP, you get about 40%. This is a huge driver for HPP is the increase in yield. Ready to eat meats. I'm kind of breezing through these. I know I'm running out of time, but sliced meats, it all started with Hormel. Hormel had a listeria issue for their Parma ham, and they bought one vertical machine, and they were using that for all their Parma ham to control listeria. But after they saw the benefit, they came out with this new label, Natural Choice. They eliminated preservatives, or most of it, and they started to use natural ingredients. And with that, their business, this product has really grown significantly. Purdue Farms, first company to do chicken strips in the Washington, D.C. area. Christem is a company out of Romania. They have 2 machines, and they do salami-style products as well as sliced meats and various other formulations. I did mention that you get a shelf life. Here is a HPP. These 2 products were designed with a 30-day shelf life. Turkey on top, roast beef at the bottom. HPP one, this is after 100 days. HPP, non-HPP, despoiled. This was a company that was actually owned by the company that now operates American Pasteurization Company in Milwaukee, Wisconsin. They sold their company to Cargill, and then they opened up. They love HPP. They came into our lab and evaluated this. This is where we got the pictures. And they love it so much that after they finished selling their company, they opened the first ever tolling process in the US. Here is an example of a salami style product that is done in Canada. And this is cooked ham after 6 months. You can see still no spoilage, while the control non-HPP products spoil rapidly. Ready meals. This is done for convenience and refrigeration and not frozen distribution. This has become very big. The frozen item category has been stagnant for many, many years. They don't grow, they don't decrease. It's just there. People who buy it, buy it. So the refrigerated aisle, if you look in your supermarket, it's actually growing for food items. And one of the things that they're doing is HPPing it for food safety, to using premium ingredients, as well as getting a clean label. So you can get this extended refrigerated shelf life by HPPing it. This chicken burrito is John Riley's customer out of California. This is a new product I just saw on the market, which is paneer butter masala. It's an HPP product. And some other examples, lasagna, is spinach and cheese manicotti. And here are some examples of those skin pack items that are done in Greece. Perfect Fit Meal is a company out of Texas that actually has several of these items in the market. We did a trial. We bought some just to see what we can get from a normal formulation and not actually formulating it. Bought some frozen items, a ton of it. We HPP some. We didn't HPP some. We stored it at refrigeration. After 2 weeks, everything spoiled that was non-refrigerated. This was after 90 days. We actually tasted this in the laboratory. Microbiologists are not supposed to taste stuff. We did taste this, and it actually tasted very well compared to items that we bought out that were kept frozen. So HPP does give you that shelf life for almost any formulations of product that you have. Plant-based products are becoming very popular. You have the Skinny Butcher, queso-style dip, which is normally cheese. Here is a plant-based item. These are burger types of product that is done in Holland. And no tuna salad. This is actually a tuna salad that is using plant-based tuna. We do plant-based tuna in other operations also, not just as a finished meal. Curry Fresh, you can go on their website. They praise HPP to getting them a successful business. All their products are HPP. They have several product lines. And they said it only needs 3 minutes to reheat and you have a full meal. Soups, there are many of these. I can show 10 different slides of the number of soups that are in the market. Baby food is the same thing. These are all HPP products. We do pet food. Pet food is a big part of what we do. There are requirements from FDA to make sure that you decontaminate products that are made that pets eat, not only for the health of the pet, but the health of the pet handlers. So companies use HPP as a decontamination process as a raw material. They either market it as is, or they further process it into other products. The Stella and Chewy's here is one of our big customers, and they do quite a few lines of HPP products that were cleaned up with HPP, the raw material, and then they go into their further processing. And I think that's the end. We do have 2 videos. I don't think we have time for them, but the links are here. The one on top is general seafood. You will see shucking of lobsters, as well as other shellfish item. And then we did one specifically for scallops. So if you are interested, you can look at those videos. And if you don't, I don't have the time to show those now. And I think that's the last slide. Thank you so much for your attention and participation. And if you have any questions, I'm here.